So, hi, algebra kids. This is for Group A going to be your lesson for Thursday the 17th, and for Group B, Monday the 21st. We're actually starting our new chapter. Chapter 2 is about systems of equations. So, some review for the most part. The page that you got in class is this pink color, but it shows up a little better for video purposes if I use this white color. So, all right, so we just want to do a quick review, take these notes, and then we'll have some practice in Schoology, some Google Slides, all right? So systems of equations, if you remember, a system is a set of two or more equations with the same, and there's lots of ways you could fill this in, but I'm going to say the same shared point. Solution to a system is a set of values for the variables that would satisfy or satisfies all the equations simultaneously at the same time. So the point of intersection of these two graph lines then is the solution. It's the point that they share to a system. Okay. So the ordered pair that satisfies both equations is also the ordered pair where they intersect. Okay. So that's the solution to a system. So if we're going to look at the methods again for solving systems, there's graphing methods and algebraic. And we're going to start with reviewing the graphing. And you did this review, the very first week of your remote learning. So hopefully you remember. Now we're just going to graph two, right? So our steps are to solve both equations for y. In other words, we're going to put those equations into slope-intercept. Now you don't have to do this if you have other ways of graphing, like in standard form, that's okay. But this is usually the easiest. Slope-intercept, remember, is y equals mx plus b form, all right? All right, so actually, what should go right here? Now I see the line. Okay, well, you can put this down here. Our second step then is that we're going to use the slope and the y-intercept and graph both lines, okay? Using, I'm trying to decide if I want to do this in another way, using the, slope, which is the m. Okay, I'm going to color code some of this. And y-intercept, which we're going to say is that b. We're going to graph both of those lines, okay? And then our last step is just to find that point of intersection. If it occurs, okay? We'll talk about that just here in a second. So this coordinate or ordered pair is the solution to that system, okay? Now this if it occurs is because there are three types of solutions that we could see if we were going to be graphing a system of equations. We could see one solution where there's this one point that they share, the one point that where they intersect, okay? But if there are parallel lines, then we're not going to have a solution. So we could see no solution. Or if it's the same line or identical lines, then we're going to have infinite solutions or infinitely many. Sometimes we might see that infinity symbol used. Sometimes we might see the null symbol used over here. Now what we have with these parallel lines is they're going to have the same slope. So the same m value, right? And different y-intercepts. Okay. Whereas with identical lines, we're going to see the same slope also. So, the same m value and also the same y-intercept. Okay, so you don't want to jump to a conclusion as soon as you see the same slope that, oh, so it could be either one of these things, right? Okay, we're going to do this practice one that's on this paper, and then there's a couple others I want to run through with you. All right, so if we were given this system, these two linear equations, y equals negative 2x plus 3, negative x plus 2y equals negative 4, our first step is that we have to solve them for y, and one's already solved for y. The equation that we need to rewrite is this one, negative x plus 2y equals negative 4. So if we're solving for y, trying to isolate y, we're going to undo addition first. So we're adding negative x. Let's put a positive x on this left side. And if I do it to the left side, I have to do it to the right side. Okay, and what's left there? Left side now is at 2y equals x and negative 4 there, right? And divide by 2. Every term gets divided by 2. And now we are at y equals x divided by 2, or 1x divided by 2, or 1/2 x minus 2. So I'm able to identify my slope, right, and my y-intercept here. Something I want to remind you of here is using the slope. Shows us how this line is going to move, and the y-intercept tells us where this line begins. Okay. So we get that y equals mx plus b. Okay. All right, well, let's just start with this first one, y equals negative 2x plus 3. We're going to begin here at positive 3 on the y-intercept, y-axis, where it crosses the y-axis. And then the slope is going to tell me to move, okay, negative 2 over 1. So it's not a line that's rising, it's falling. It's going down 2 on the y, over 1 on the x, right? So down 2 over 1. Down 2 over 1, down 2 over 1. And good idea to just get as many points as you can to make this as accurate as you can. It was one thing maybe when we were doing this for just regular graphing, but when we're trying to do system of equations and we're looking for where they intersect, we want to be as accurate as we can. Okay, so make sure you're using a straight edge. I kind of like this clear ruler so I can see through it. And there's our first line. Okay. And then the second line, we're going to begin at negative 2. And its slope is 1 over 2. We're going to rise 1 on the y-axis and run 2 on the x. So up 1 over 2, up 1 over 2, 1 over 2. And we can see, you know, where it intersects very quickly, right? But again, we want to be as accurate as possible. And we want to make sure that we're graphing properly, which means it's going to go completely through our coordinate grid. Okay, so there's our second one. So for our system, this is the point of intersection, correct? So that is at 2, negative 1. And it's really important that we write that as an ordered pair, okay? Okay, so you don't have this, but I'm going to do 2 more examples with you, all right? This one here. So y equals negative 2x plus 2. That one again is already solved in slope intercept, so I could begin at 2 and go down 2 and over 1. Looks familiar, huh? Just like one we just did. And okay. And then if I'm going to go in a reverse order, we read graphs from left to right. But I want to graph from right to left, then I'm kind of reversing that, right? Where now it's going to be a positive 2, negative 1. So if I just put that negative in the denominator instead, I can go backwards, okay? Because 1 negative, whether it's in the numerator or denominator, is going to make that a negative fraction, right? Tend to think of that negative as being in the numerator because that's the rise or the fall, the change in y, the up or down, right? Okay, now this one is not in slope-intercept, so I'd have to solve it. To get y alone, I'm going to need to subtract 2 from both sides, right? And I'm going to move it over here, y, that's gone, equals negative 2x minus 2. Okay. Let's see, they have the same slope, but they have a different y-intercept, right? So, negative 2 for the y-intercept, okay? And this one's going to go down 2/1. I already know, again, that these having the same slope and different y-intercepts are going to be parallel. But, you know, if this is what we're asked to do, is solve it by graphing, then I need to do that. I need to show it. This is my evidence of my answer. So just by graphing it like that, I haven't given my solution. I've shown how I arrived at it. I have to say that there's no solution to this. Okay, one more. And you can move on to your practice. Okay, this one. Again, top one is already solved for us for y. We don't see a slope there, but when it's not there, it's just that invisible one. That 1 times x is the same as just x. And that's the same as 1/1 as well. So we're going to begin at negative 4 on the y-intercept right here. And that is a positive 1 over a positive 1. So we're going to rise up 1/1, up 1/1, up 1/1, up 1/1. 1, 1, up 1, up 1, up 1, right there. There we go. Okay. And there. And then our next one, have to solve for y. So we're going to subtract 4 from both sides. I get y equals x minus 4, which is the exact same equation, right? Beginning here at 4, going up 1/1, up 1/1, up 1/1. And this is why whenever I'm going to do like systems of equations like this, I usually like to do 2 different colors, because yes, they're going to be the same line, but if we can just see a little bit of both of those colors, it might make it a little more obvious that it's the same line. It's just one on top of the other. So when we see that, we're going to share all possible points. So every point on both lines is a solution. So we would say there are infinite or infinitely many solutions. Okay. All right, so these notes you're going to need to hold on to, put them in your physical notebook. Your teacher's probably going to want to give you some points for having those completed. So put those someplace safe. If you need to refer back to it, you can, obviously, when you're doing your practice work for this assignment. And that is going to be some Google Slides that you'll find in Schoology. Remember, you need to submit them. You can work outside of Schoology on Google Slides, but for us to be able to give you a grade for it, you have to submit it in Schoology. Make sure, again, you're using Chrome or Firefox and that you are signed into your Google account so that the Google Slides will open up for you and create a copy. Okay. Any questions or help you need, remember Monday office hours. Monday office hours this week have changed, though. They don't start till 12. But yeah, let your teacher know if you need anything, okay? Good luck.